Hello, everyone. I hope you are in high spirits. My name is Hagar Ibrahim, and I'm very delighted to present to you my KaggleX project showcase. We're going to talk about stock price prediction using time series models. So we're going to cover many headings, including a brief introduction to my educational and career background. Next, a concise explanation of the stock market domain and its functioning. Following that, we'll discuss the main objective of this project and outline the workflow followed while working on it. In addition to the deep learning models used in this project, lastly, the conclusion. So let me start by giving an overview about my own background. I had a bachelor's degree in computer science. Additionally, I have 2 diplomas from the Information Technology Institute in Egypt, known as ITI. The first diploma focused on software development and cross-platform mobile applications, while the second diploma was powered by ITI in cooperation with the School of Engineering and Computer Science in France, focusing on data science and machine learning. Furthermore, I had studied governmental leadership and digital transformation at the School of Business, Missouri State University in the USA. I also possess a certificate from the Beijing Language and Culture University. In the early stages of my professional career, I worked as a software developer. However, my passion led me to join the vibrant data science community. As part of my journey, I had the opportunity to work as a teaching assistant at ITI. Currently, I'm a senior data scientist. Beyond my professional endeavors, I enjoy Kaggling so much. I'm a Kaggle notebook expert, and I've just earned my text medals. Continuous learning and personal growth are integral to my career aspirations in data science. I'm dedicated to expanding my knowledge and skill set in this field by staying updated with the latest advancements in data science and machine learning techniques. I aim to gain exposures to diverse industry domains. Now let's have an overview of stock market domain. The performance of a country's financial market is a crucial determinant of its overall economic condition. Among the various financial markets, the stock market stands out as a key driving force. NASDAQ, S&P, and NYSE are well-known examples of stock market indices and exchanges. Here is a brief explanation of it. NASDAQ stands for the National Association of Securities Dealers Automated Quotations. It's known for its focus on technology-driven companies such as Apple, Microsoft, and Amazon. S&P, short for Standard & Poor's 500, it's a stock market index that measures the performance of top 500 large publicly traded companies in the United States. NYSE stands for the New York Stock Exchange, which is one of the largest and oldest stock exchanges in the world, providing a platform for buying and selling various types of securities, including stocks, bonds, and so on. The NYSE is known for the Wolf of Wall Street movie, if you have seen it. So, why do you think it's important to predict stock prices? Well, in order to answer this question, we need to know that due to the unpredictable nature of the stock market, it's highly difficult for individuals to obtain returns on their investments. It is imperative for investors to identify the opportune moment to sell shares and achieve returns. In all cases, investors and the traders need to know predictions so that they can build strategies or enhance existing ones. In the current era, stock price prediction using machine learning and deep learning algorithms offers substantial advantages over traditional techniques used for analysis and forecasting. Leveraging the power of machine learning and artificial intelligence, these algorithms help to identify that opportune moment for investors by discovering the future value of a company's stock and other financial assets traded on an exchange. After having a comprehensive understanding of the stock market domain, it is now crystal clear that our project's primary objective revolves around forecasting stock prices. We achieve this by examining various time series analysis algorithms and leveraging deep learning methods to identify the most effective performance. Through our pursuit of this objective, I have learned so much about the essential components of time series forecasting. Furthermore, I have developed my skills in building various models and applying them to a real-world forecasting data. Moreover, I have implemented several data science topics, such as exploratory data analysis for time series data. Additionally, many deep learning models, including different architectures of artificial neural networks, such as CNN, LSTM, Notably, I have also explored the autoregressive LSTM with the pros and cons of each one of them. For my project, I used a Kaggle dataset called stock market data. The dataset is regularly updated on a weekly basis and includes the stock prices of all companies listed on the NASDAQ, S&P, and NYSE stock exchanges. My primary focus was on the American Airline Group Incorporated, which is listed on the NASDAQ stock exchange. The stock prices of this company were recorded from September 2005 till December 2022, resulting in approximately 4,333 records. The dataset contains 7 main features, including our target variable, which is the closing price. The closing price of a stock refers to the last price at which a stock was traded during the regular trading day. I followed the typical steps of a machine learning model pipeline for predicting stock prices, starting with data wrangling and pre-processing phase, which includes handling missing and categorical data. In addition to data resampling, as is possible that the data sampled every day is too noisy to build a performant predictive model. Then I perform feature engineering, including feature selection, in addition to identifying seasonal periods. After that, we split the data into training, validation, and test sets, as well as applying data scaling transformation. Moving forward, I've trained various models, including 2 baseline models, serving as a benchmark of our sophisticated models, which are a linear model, deep neural network, LSTM, CNN, combination of LSTM and CNN, and finally, an autoregressive LSTM. Lastly, I use the mean absolute error as an evaluation metric in order to compare all the models' performance. And here we come to the $1 million question. What is the best performer model? We can see from the graph the mean absolute error scores for each model, which indicate that our champion is the autoregressive LSTM, since it achieved a mean absolute error of 0.035 on the test set, which is the lowest mean absolute error of all. The second best performer is the linear model, with a mean absolute error of 0.044. It's also worth noting that all the models performed much better than the baselines. And we have reached the end of our journey. You're warmly invited to check the notebook on Kaggle, where I have provided more advanced details about the workflow. You are most welcome to share your thoughts in the comments as well. In conclusion, let me summarize the key points covered in this showcase. To begin with, we had an introduction to the stock market domain. Then we discussed the project objective and the workflow I followed, which includes all stages, along with the implementation of 8 different deep learning models. During working on my project, I came across some valuable resources. Firstly, I found the book Time Series Forecasting in Python to be incredibly insightful. Additionally, I benefited from attending various KaggleX workshops as part of the mentorship program. I'd like to end my presentation by acknowledging KaggleX Mentorship Program for offering this learning opportunity. It's been a challenging experience in terms of time and commitment, yet enlightening, incredibly enriching, and ultimately rewarding. I also would like to acknowledge my mentor, Muhammad Hassan, for his guidance and support. Thank you for taking the time to engage with my presentation, in which I aim to provide a comprehensive understanding of my KaggleX showcase of time series forecasting models. I sincerely hope you found the information valuable and insightful as much as I did. And I'd be delighted to receive any of your questions on the following contact info. Please have a nice day.